Welcome back to CJT, the second day where we'll be dealing with measure of variability. This is our chapter 2. Measure of variability. Measure of variability can also be called measure of variation, measure of dispersion, or measure of scatter. Now, the main measure that are used in education, when we talk about measure of variability, we'll be talking about 4 different measures. First, we'll talk about the range. Second, we'll talk about the variance. And third, we'll talk about the standard deviation. And the last one we'll talk about is the quartile deviation. These are the 4 measures we would look at in today's topic. Let's start with the range. Dealing with the range, all that we are interested is to locate or find the highest number within a set of observation and find the lowest number within a set of observation. Then we can therefore conclude that range. So range is simply equal to the highest value minus the lowest value. Now, the highest value within the set of observation, what is the highest value? Within the set of observation, what is the lowest value? When we take the highest value minus the lowest value, you will derive at getting the range. For today's class, we'll be dealing with the ungroup data as usual. Now, let's look at the features of the range. It is easy to compute. It is easy to interpret. It's a good measure of dispersion and does not take into account all the values that makes up the distribution. Are we good? Now, let's move to variance. I will treat variance and standard deviation together, since we are interested in ungroup data than the group data for today's class. Now, all I'm interested in variance and standard deviation is your ability to know when you are given a standard deviation and are asked to find a variance. How do you get it? When you are given the variance and you are asked to find the standard deviation, how do you get it? That is our interest for today. If we give you standard deviation and we ask you what is the corresponding variance, how do you do it? And if we give you the variance and we ask you what is the corresponding standard deviation, how do we do it? Now, when you are given the standard deviation, and you are asked to find the variance, the standard deviation is 9. And you are asked to find the variance when given the standard deviation to be 9. Simple. Our variance will be the square. Our variance will be the square of the standard deviation. So when we take the 9, which is the standard deviation, and you square it, the response will be the variance. So the square of 9 will be 81. So 81 is our variance, our corresponding variance for the standard deviation of 9. On the other hand, if you are given the variance and you are asked to find the standard deviation, the corresponding standard deviation, then what it means is that you find the square root of the variance. Let's assume that this 81 is our variance, and you are asked to find the corresponding standard deviation. What do? We take the square root of the variance. And what is the variance? 81. So the square root of 81 will give us what? 9. Therefore, our standard deviation is So the rule is very simple. The rule is that whenever you are given the variance and you are asked to find the corresponding standard deviation, you just need to take the square root of the variance to get the standard deviation. Is that okay? And when you are given the standard deviation and you are asked to find the corresponding variance, all you need to do is take the square of the standard deviation and you will get the variance. Let's look at the features of the variance or standard deviation. The features. We will talk about this. The standard deviation of variance of a constant is 0. For example, let's assume that you have written a quiz, and in the quiz, after marking, you all add 8. So the 5 of you in a class all add 8. So 8. Now these are the scores for the 5 of you. Okay, so you realize that you have a score of 8. This 8 is a constant. When you are asked to find the standard deviation for this distribution will be 0, because that is one of the features of the standard deviation of variance. Now, since it is a constant, we are saying that the standard deviation is 0. So if you are giving standard deviation to be 0, what will be the corresponding variance? Have you seen? So when you take the square of 0, you would get 0. That is why the variance is also 0. So with the standard deviation for a constant is 0. How we go? Now let's look at the second feature of the standard deviation. It is not resistant. It is affected by extreme scores or outliers. Remember, during our first chapter, we talked about the mean, and we said the mean is sensitive to extreme values or extreme scores. And remember that whenever we change a given score within a set of observations, okay, the mean also changes. In the same way, when we change a given score, okay, within a set of observations, the standard deviation also change. Are we good? And if the standard deviation changes, then it means that the variance will also change, because we take the square of the standard deviation to get the variance. Now, there is 2 things I would like to talk about under the features, which are the standard deviation is independent of change of origin. Okay. Now, if each score in a set of data is reduced or increased by the same amount, which is a constant, the standard deviation of the new set of data does not change. That is the change of origin. So, for example, 2, 4, 6, 8, and 10. Let's assume that the standard deviation for this score is 4. This is an assumption, okay? Assumption. So the standard deviation for this score is 4. Assumption. Now, let's assume that I decide to add 5 marks across board, okay? I decide to add 5 marks across board. Our new score will be 7, 9, 11, 13, and 50. This will be our new score. What will be the standard deviation? This is what we are saying. We are saying that there is a constant. Yes, we agree. You realize that there is a constant of what? 5 across all. This 5 is added to every individual score, which has given us a new score. Okay. Now these are the new scores for the 5 of 3. But we are saying that whenever a constant is added, increase or decrease, okay? So when we add or subtract from your scores, the standard deviation would not change. So the standard deviation for this score will still be 4. Are we good? Very good. That is the change of origin. Now let's look at the second concept, which is the standard deviation is not independent of change of skill. Now before I go to the change of skill, in a change of origin, we deal with addition and subtraction. So increase or decrease. While the change of skill deals with multiplication and division. What does that one say? It says that if each score in a set of observation or data is multiplied by a constant, okay, the standard deviation, which is the old one, would also be multiplied or divided by that constant. Are we good? So for instance, let's assume scores, okay, 2, 4, 6, 8, 10, and let's assume our standard deviation is 4, okay, and now we are multiplying these scores by 2. So what will be our new score? 4, 8, 12, 16, and 18. Now this is multiplication, okay, and this is change of skill. So in multiplication, what we are saying is that the standard deviation, okay, the old one, because we are multiplying the score, we are multiplying through the score by what? By 2. So all the individual scores are multiplied by 2. Therefore, the old standard deviation is what? 4. So we need to multiply the old standard deviation by the constant, which is what? 2. That's giving us what? 8. So our new standard deviation will be what? Will be 8. Are we good? So it tells you that with the change of origin, okay, addition and subtraction is what we do there. So either we add or subtract, the standard deviation does not change. But with change of skill, multiplication or division, so if we multiply the score by a constant or we divide the score by a constant, okay, the standard deviation is either multiplied by the constant, the old one is multiplied by the constant, or the old one is divided by the constant. Are we good? Now let's look at the uses of standard deviation. It is used as the most appropriate measure of variation or dispersion or spread when we believe that the distribution is normal. Don't forget, in our chapter 1, we said that when the distribution is normal and the measure of central tendency, which we did the last time in chapter 1, okay, I told you that the most appropriate one when we believe that it is normal is the mean. But today's class, we are saying that if we believe we have a normal distribution and that the measure of variation, the measure of spread, the measure of scatter, the most appropriate one to use here is the standard deviation when we believe that the distribution is normal. Are we good? Now, it is used for further statistical analysis. Are we okay? Now, it is helpful in determining the reliability of a test score. That is one of the use of standard deviation. It is helpful in determining the reliability of a test score. Are we okay? Now, let's go to the last measure, which is quartile deviation. The next measure of variability, which is quartile deviation. Don't forget, we said that if we believe that the distribution is normal and that the measure of variation, the measure of variability, the most appropriate one to use is the standard deviation. Are we good? And don't forget that when we're dealing with our previous chapter, and a measure of central tendency, measure of location, or we also said that they can be called averages. We also said there that if the distribution is normal, the most appropriate measure to use there is the mean. So you would know that for normal distribution, the mean goes with the standard deviation. But the mean is under the central tendency or location, while the standard deviation is found under the measure of variability or scatter spread dispersion. Now let's go to quartile deviation. In quartile deviation, it is also called semi-interquartile range. Are we good? In quartile deviation, we also call it semi-interquartile range, and it depends on the quartiles that we will be dealing with. Are we good? Now, quartiles divide distribution into 4 equal parts. It's just like you bisecting an orange, okay, into 4 equal parts. You see, you have 4 parts. When you bite the orange, you bisect it into 4 parts, like 1, 2. So you have 1 part, 2nd part, 3rd part, and the 4th part. So 1st, 2nd, 3rd, 4th. It's the same ideology we'll be using in the quartile deviation. Now, the quartile deviation is half the distance between the first quartile and the 3rd quartile. Is half the distance between the first quartile and the 3rd quartile. How we do? And the 3rd quartile. Now, the quartile deviation denoted QD can be derived by using the formula Q3 minus Q1 all over 2. And don't forget, we said that the quartile deviation is also known as the semi-interquartile range. Are we good? But when we say you should calculate for the interquartile range, then that's why the interquartile range will be Q3 minus Q1. Are we good? Because of we have removed the word semi. So it is the interquartile range. So it is Q3 minus Q1. Just like the range, when we say the highest value minus the lowest value. So in quartiles, Q3 is the highest value and Q1 is the lower value. Are we good? Now, there are 2 methods we can use to derive getting the quartile deviation. We have the median method and we have the formula method. Are we good? Now let's deal with the median method first. Let's go back to our observation. Let's assume you have these observations: 4, 6, 7, 8, 9, 10, 12, 13, 18, 22, and 25. I repeat, we have 4, 6, 7, 8, 9, 10, 12, 13, 18, 22, and 25 as our observation. So, we have 4, 6, 7, 8, 9, 10, 4, 6, 7, 8, 9, 10, 12, 13, 18, 22, and 25. 12, 13, 18, 22, and 25. So these are the median formula rules. Now, unfortunately, the scores are already arranged. If the scores were not arranged, okay, you have to rearrange the scores either in ascending order or descending order when you are dealing with the median. But then, the best way to arrange the scores is to arrange the scores from the smallest to the biggest, which is the ascending order. Okay, I would prefer you arrange them in the ascending order. So it has been arranged from the smallest value to the biggest value. Is that okay? So the appropriate way is to arrange the scores from the smallest value to the biggest value. So now we have to locate the middle number from the given observation. Now you realize that the middle number from the given observation is 10. Now you see, I've circled 10. It means that there are how many observations? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. There are 5 observations falling below the median and 5 observations falling above the median. Are we good with that? Now, the observation that falls below the median, okay, that is where we can locate our first quartile. And the observation falling above the median, that is where we can locate our third quartile. Now, we have 5 observations falling below the median. 5 falling below the median. What is the middle number within that 5 observations? You realize it is 7. Okay, so it means that our Q1 is equal to 7. Are we good? Now, we have 5 observations falling above the median. 5 observations falling above the median. What is the middle number then? You realize it is 80. Are we good? So this is our Q3 and this is our Q1. So Q3 is equal to what? 80. Then to get the semi-interquartile range, which is the same as the quartile deviation, we can say that Q3 minus Q1 all over 2. So we can end up saying that 80 minus 7 over 2, which is giving us 11 over 2, which is giving us 5.5. So 5.5 is our quartile deviation. I hope we are good. Now, assume you have 2 numbers at the middle. What do? What you do is you sum up the 2 numbers, or you add the 2 numbers and then you divide by 2. Hope we are good. Very good. Now let's look at the formula method with the same given observation. Numbers. Let's look at the formula method with the same observation we used for the median formula or median method. Now, with the formula method, okay, first you look at the distribution. If it is not arranged, you rearrange them from the smallest value to the biggest value, okay, which is the ascending order. Okay. Now, we need our Q1 and we need our Q3 before we can solve for quartile deviation. Now I told you, quartile is divided, or quartiles are divided into 4 parts, right? So if Q1 is the first quartile, then our Q1 will be equal to 1 out of 4 into bracket n plus 1. This will give you the position in which you find the first quartile, but that is not the quartile. It will give you the position, okay, in which you find the first quartile. If you need the third quartile, because quartile is out of 4, and we need the third quartile to be 3 out of 4 into brackets n plus 1. This will also give you the position in which you find the third quartile, but not the quartile itself. Are we good? Now, let's look for the positions in which we will find the first quartile and the third quartile. Are we good? Now, this n here is representing our number of observations. So what we have to do is that we have to count. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this is saying that our n is equal to what? 11. Are we good? So let's find the position in which we find the first quartile. So 1 out of 4 into bracket 11 plus what? 1. Are we good? Now when you do this, you get 1 out of 4 into bracket 12. When you do everything, you end up getting third position. Now, it means that on the third position on our observation, okay, the third position on our observation is telling us that that is the third quartile. The third position on our observation, that is the first quartile rather, sorry, okay. The third position on the observation is telling us that that is our first quartile. So it means that this number is the first position, second position, and 7 is on our third position. That is saying that Q1 is equal to what? 7. Are we good? Now we do say for the third quartile, okay? So 3 out of 4 into bracket 11 plus 1, which is giving us 3 out of 4 into bracket 12. What are we getting? We'll be getting 36 out of 4. Are we good? So 36 out of 4 will give you what? 2 year 2, 2 year 18. 2 year 1, 2 year 9. So you get the third quartile on the 9th position. You get the third quartile on the 9th position. That is where we can locate the third quartile. Always we start from the smallest. So these are first, second, third, fourth, fifth, sixth, seventh, eighth, 9th. So you observe that the number 18 is on our 9th position. So our Q3 is equal to what? 18. Are we okay? Are we good? So to get our quartile deviation, we can therefore say that Q3 minus Q1 all over 2, which is 18 minus 7 over 2. You end up getting 11 over 2, which is giving us 5.5. That is how we would use, or that is how we can use the formula method to calculate for the quartile deviation for ungrouped data. So all what we are doing so far is for ungrouped data. Thank you so much. Like, subscribe, and share. Stay tuned for updates from CJ TV. Thank you so much.